Hmm. Hello everyone. My name is Satyam, and in today's stream, we are going to talk about MINA. MINA is a layer 1 blockchain which uses zkSNARK technology. And you know, the reason I decided to cover MINA is uh, least of all, it's interesting, right? Like the size of the blockchain is fixed 22 kilobyte, which is really difficult to wrap the head around at the first sight. So yeah, I decided to dig deep into it. The ecosystem is very mature, and there are very good developers working in the ecosystem. So I decided to give it a shot. And yeah, in this stream, we are going to create a very basic mina application. We are going to talk about the mina architecture, and you know where things stands for mina right now. So we are going to do all of those things, and hopefully I'm going to create a bunch of other streams on Mina, covering specific topics like recursive proofs and L2 solutions for Mina, and off-chain storage, and all those sort of things. So the best place to start is starting with the Mina docs, docs.minaprotocol.com. And again, you can find all of those links in this overview page that will be in the stream's description. So yeah, so Mina is a layer 1 blockchain with a 22 kilobyte blockchain and zero knowledge smart contracts written in TypeScript. So yeah, to create a smart contracts on Mina, you are going to use TypeScript, and specifically you are going to use o1Js package. And this is a very nice abstraction. Instead of introducing some other low level language like for other GK based chains like Cairo and Leo, Mina decided to go with this abstraction o1Js. And I think it really plays a good role in the developer experience thing. And it really helps people who wants to create an application. There is not that steep a learning curve, but again, there is a trade-off, right? So with this stuff, you would have to depend on o1Js team, how soon they will be able to support the other features. And so yeah, this trade-off thing. Okay. And about Mina, let's go with Mina overview. Mina is an L1 blockchain based on zero knowledge proofs with smart contracts written in TypeScript. It is the first cryptocurrency protocol with a succinct blockchain. So there are two terms here which are important. So zero knowledge, zero knowledge proofs. Okay. And let me like make it bold. Okay. And the other one is succinct blockchain. So okay, I mean, let's talk a bit about the zero knowledge proofs, because I guess I'm just assuming that you guys are not aware of this. And zero knowledge proof is this or zkP, zero knowledge proofs, short form zkP, is this really amazing mathematical mathematical solutions which allows you to prove a statement without really revealing without revealing the information about the statement. I guess more or less that's really the case, but it's it becomes difficult. People who are are watching this, and they're like, what the heck this is, right? What the fuck this is, like, what the fuck this means. So uh, let's take an example, right? Like, where is there in zkP world, there is this very famous example, where is Waldo, and where is Waldo? So basically, the idea of where is Waldo is so like we just search like, okay, where is Waldo? Okay, uh, yeah, mm, we can, like, where is Waldo? Let's open this thing. Okay, so basically, what is this game is that you have this, fancy character names Waldo, and you have this sea of people, right? There you have this sea of people, and in this you have to find the Waldo. And how the zero knowledge proofs plays into the picture, right? So the example is with the zkP or zero knowledge proof. I can prove to you, okay? I can prove to you that I know the location of Waldo in this picture, okay? Without actually telling you where is the Waldo. So that's the idea, right? Isn't this amazing? Like, I can somehow prove to you that I know the location, and at the same time, I am not revealing you the answer. So I am not revealing any knowledge about where this Waldo is, but still I will be able to prove that I know this information. Okay, let's see a couple of ways where, how we can prove that. So let's say the first idea would be, what I'll do is, let's say, I'll take this picture, and and I'll take a very big paper, right? Very big paper on top of that picture. Like, if the picture size is, let's say, like 100 by 100 centimeter, 1 by 1 meter, right? And I take, let's say, 100 by 100 meters picture. So you don't know beside that paper where this picture is, and I'll just cut that particular portion for the Waldo, and I'll show you the Waldo from behind that picture. So you will know that I know the Waldo, but at the same time you don't know where that paper exactly is. So what is that Waldo's location? That's like the one way of proving that, right? The other way of proving that is like, I can make a copy of that picture, right? This exact copy, and I'll just cut the Waldo part, and I'll I'll give this that part to you, and I'll be only able to do that if I know the location, right? So these are, couple of ways where I can prove that I know the location of this, really funny dude, Waldo, without actually revealing, right, where this Waldo is. So that's the idea of zero knowledge proof, right? And if we can extend this idea, is like, okay, uh I know, let's say, I know, I know data whose hash is X, okay? And I want to prove this. I want to prove, I can prove this with zkP. So that is the idea of zero knowledge proofs. I hope, like, you got this picture. So you can prove a statement, and you can prove a statement without actually revealing the information, and that hidden information is called witness in zkP terms, like, without actually revealing the witness. So I can prove statement without revealing any information about the witness, any information about the witness. Yes. And I know like, there is this thing that, what do I say, zkPs are like really huge, like, and especially in the blockchain domain, zkPs, that it's like the revolutionary technology, right? So because, like, in the L1 solutions with the Ethereum, right, the gas fees is very high, so I can use zkP solutions as a roll-up solutions, where I can prove that, I have executed those 10,000 transactions off chain, and I can just give you the proof that I have executed it. So GKPs have multiple solutions. So yeah, I mean, I would all I can do is like suggest you some very good resources. So there's this very good website zkAPP.dev, and here, like, if you watch like first 2 3 videos by then you will get a pretty good idea of what zkP is. But yeah, I mean, that's pretty much it about the zkP. I'm not going to cover the mathematics part in this stream, though maybe I should cover it in separate streams. But okay, let's come back to the mina. So what is mina? Mina is a L1 solution based on zero knowledge proofs with smart contracts written in TypeScript. It is the first cryptography protocol with a succinct blockchain. Okay, now why mina? Okay, so MINA protocol uses zero knowledge proofs to build a more ideal blockchain structure. Okay, early blockchains like Bitcoin and Ethereum accumulate data over time and are currently hundreds of gigabytes in size. So as the time goes on, the blockchains will continue to increase in size. The entire chain history is required to verify the consensus state of these networks. Actually, it's not entirely true. There are, like, light clients, and there are whole bunch of solutions, so that you don't have to spin up the entire Bitcoin or Ethereum node in order to be network participant. But yeah, okay, I agree. Like, even there is this problem of chains growing in size exponentially, like hundreds of gigabytes of size as there are more and more transactions. So yeah, it makes sense. With Mina, the blockchain always remains a constant size, about 22 kilobyte, the size of a few tweets. Okay, it's possible to verify the current consensus state of the protocol using this one recursive 22 kilobyte zero knowledge proof. This means participants can quickly sync and verify the current consensus state of the network. Okay, so that's basically the idea. And what are zero knowledge proofs? Mina's unique characteristics are made possible using zero knowledge proofs, and there are bunch of resources for the zero knowledge proofs all over the internet. But you can see this video as well. What are zkAPPs? So Mina's zero knowledge smart contracts are referred to as zkAPPs. zkAPPs provide powerful and unique characteristics such as unlimited off-chain execution, privacy for private data inputs that are never seen by the blockchain, the ability to write smart contracts in TypeScript, and more. Okay, how does consensus work on Mina? The Mina network is secured by proof of stake consensus called Ouroboros Samisica. Very funny name, huh? Ouroboros Samisica. Okay, based on Cardano's Ouroboros Samisica is a proof of stake consensus mechanism that requires far less computing power than Bitcoin's proof of work protocol. Okay, so with this model of Mina's consensus mechanism, you don't need expensive and energy consuming mining equipment to participate in consensus. Yeah, I mean, if it's a proof of stake mechanism, it won't require that much energy, and yeah, uh, that much, high GPUs and all sort of thing. By simply holding Mina in a wallet, you can choose to stake it yourself while running a block producer node, or delegate your Mina to another node. Uh, I haven't actually tried that, but it seems to be a very good idea that, I try some staking stuff as well. Zero knowledge proofs keep Mina's blockchain light and your personal data private. In this video, Brandon from o1Labs explain what zero knowledge proofs are by comparing them to the game of Where's Waldo. Again, like, like at this point, Where's Waldo is like, a classic Hello World example, just to explain what zero knowledge proofs are. So learn more zero knowledge proofs, where they are, and blah blah blah. Mina protocol architecture. So Okay, like I watched this dude's video and it's just pretty amazing. Like, this is like the most amazing education videos I've seen in terms of blockchain architecture. So I would highly recommend you to watch this video. And mm, you know Mina started itself as a coda protocol. So in this video, the names are interchangeable, but you get the point, right? Mina protocol uses proof of stake or over a samsika. Okay, Mina security. Okay, Mina FAQ. We are not going to go down on that. So okay, install a wallet. I already have a Oro wallet. So let me see. I have already have the Oro wallet, so we don't have to install that. But you know, you got the point that okay, this is my main net balance. Okay, and okay, so you can install Oro wallet, Glorio wallet. There are like a bunch of other wallets, but I would suggest if you're following this, just go with the Oro wallet. Receiving Mina, blah blah blah. This is just typical stuff. Okay, how to delegate, how to use a zkAPP. So uh, right now zkAPP programmability is only on Berkeley network. So yeah, I mean, we are going to use Berkeley network for now. Okay, zkAPP. So you just visit the, I don't know, like if this is available, but anyway, I have a zkAPP, so I'll just show you what that means. Ah, really? Okay. Okay. So visit the zkAPP in a browser, interact with the zkAPP as intended. For example, make a move in a game, enter your age, and so on. Click the confirmation button to send the transaction to the Mina network. In Mina browser extension wallet, confirm the transaction, and that's pretty much it. Okay, now we come to the very important part. How this zkAPPs, how we develop the zkAPPs, right? So okay. So zkAPPs or zero knowledge apps are Mina protocol smart contracts powered by zero knowledge proofs, specifically using zk snark. Snark, succinct non-interactive argument of knowledge, right? It's a zero knowledge solution. That's okay, that's just another thing. So zkAPPs use an off-chain execution and mostly on-chain state model. Okay, let's understand that what this means, right? So this is because this is very important. So zkAPPs use an off-chain execution and mostly off-chain state model. What does this mean is that uh, you know whenever you are using any application, or I should say zk application that is on top of Mina. Let's say it's just a web application, right? So if you are doing any stuff, right, that execution is happening right inside your browser. If it's a web application, right, it's a mobile application, right, inside your mobile device, right inside your browser. And at the end of that execution, you will get this proof, right? You can think of a proof as some long string, like okay, 80 character string or 100 character string, right? So the entire trans execution, code execution, it happens off chain. It is not happening on chain. Okay. And and why it is saying like mostly off chain state model? Because Mina blockchain, right? Mina blockchain size is fixed, right? 22 kilobyte. So every zk app account, it's just like it allows you to store, I would say, like 8 fields, like very few bytes of data per account. So you would store most of the state, right, on most of that contract state off chain, and you would store some sort of hash or other thing on chain. So that's basically the idea, and that's that off chain state thing is done, I think, to keep the blockchain very light. So that's basically the idea. This architecture allows for private computation and state that can either private or public. And like, uh, I feel really bad that I am not, covering very small part, but you have to understand, right? Like, this is not a blockchain 101, right? Like Mina blockchain, it's not a very blockchain. It uses advanced solutions like zero knowledge proofs and like cutting edge solutions. So that is why sometimes there is this prerequisite knowledge to understand that. Like for example, if you understand what are the transactions, what are the norms, and what is off chain data versus on chain data, it becomes a bit easy to understand these solutions. And because I feel like sometimes, like, anybody might be wondering, okay, what is this zk, right? Why zk, why focusing so much on gk? And the thing is, you can only appreciate the beauty of zks if you have faced the issue of like high transaction gas fees, or this latency when working with ethereum and other chains. Because those chains, like traditional chains, or what we can say like classic chain, sometimes gas fees was like up to $50, $100 per transaction. And all of these solutions, zk solutions, or other l2, other, like optimistic rollups and other things, they solve these things. And due to these solutions only, blockchain can be mainstream. So yeah, I mean, they play a very important role in a blockchain adoption, which is I think everybody working in the blockchain industry wants, right? So we are not building projects just to keep them in our GitHub repositories. So yeah. So this architecture allows for a private computation and a state that can be either private or public. Okay, zkAPPs can perform arbitrarily zkAPPs can perform arbitrarily complex computations off-chain. Okay, and while incurring only a flat fee to send the resulting zero knowledge proof to the chain. So I'm talking about this proof, right? The resulting zero knowledge proof for verification of this computation. This cost-saving benefit is in contrast to other blockchains that runs computations on-chain and use a variable gas fee based model, right? So if we are using ethereum, like simple ethereum l1, any if you are trying to, let's say, do a transaction that finds out the factorial 10, right? That computation is happening on chain, which takes a gas fees, right? And if it is a very complex computation, it is going to cost you more money. So this is really nice solution to doing the computations off chain and just prove, sending the proof to on chain in order just for the verification. This is amazing. Yeah. So okay, TypeScript, zkAPPs are written in TypeScript. TypeScript provides an easy, familiar language, but with type safety, making it easy to get started writing zkAPPs. Okay, example of zkAPPs for proof of trade performance. These are example of zkAPPs. Okay. Okay, now we comes to the part of how zkAPPs work. Okay. So zkAPP programmability is not yet available on the MINA mainnet. You can get started now by deploying zkAPPs to the Berkeley testnet. Okay. How zkAPPs work? zkAPPs runs in the latest versions of Chrome, Firefox, Edge, and Brave web browsers. zkAPPs are written in TypeScript using the zkAPP CLI. Okay, so any zkAPP consists of two parts. One part is the user interface part, like uh, user connecting their wallet and interacting with the zkAPP. For example, let's say if that zkAPP is a chess application, then user clicking to move their pawns and rooks and all those things. Then there is the other part is the smart contracts, right? So smart contracts, they gets methods in smart contracts gets executed upon user interaction, and at the end of that method execution, some proofs getting generated, and we can send this proof to on chain, and as for the verification that whatever the operation user did was correct, in line with the contract rules. So that's how the zk flow works. Okay, the term smart contract refers to the code written with o1Js. o1Js is a package developed by the o1Js labs, and you write your mina contracts with o1Js. Yeah. Okay. The term zkAPP refers to the UI plus smart contract. Hmm. Okay. So what is saying zero knowledge based smart contracts? zkApps are zkApps are based on zero knowledge proofs, zk snarks. As a zkApp developer, you use the zkApp CLI to scaffold and deploy a project. Yeah. So zkApps are based on zero knowledge proofs. As a zk developer, you use the zkApp CLI to scaffold and deploy your project. We'll come to the scaffold part. I mean, I already have the box, I already have a pretty good scaffold for the contract and the UI. So I am anyway going to put it in the streaming part. So, mm, so yeah, like whether it is a private or public, I'll make it public if it's okay. Let me just check it right away. Public, yeah, this is public. Okay, so provable code is written using o1Js and generates a prover function and a corresponding verifier function that are derived during the build process. So what it is saying is like when you build your contract, it generates a prover function and corresponding verifier function. That's it. The prover function is the function that executes a smart contract's custom logic and runs in an end user's web browser as part of the zkAPP. The prover function generates a proof of the executed code. When interacting with the zkAPP UI, user enters any data, for example, by AVC for Y price, that is required as input to the prover function, which then generates a zero knowledge proof. So what it is saying is when interacting with the zkAPP UI, user enters any data that is required as input to the prover function, which then generates a corresponding zero knowledge proofs. So I think when we'll talk about when we see the code, the example, I think it will be pretty self-explanatory. Okay, private and public inputs represent data that must be provided to the prover function when it runs in the end user's web browser. Private inputs are not required again because public inputs must also be provided to the verifier function when it runs on the MINA network. Public inputs are not used for data that you want to remain private. Verifier function validates whether a zero knowledge proof successfully passes all the constraints defined in the prover function. The verifier function always runs quickly and efficiently irrespective of the prover function's complexity. Within the MINA network, MINA acts as the verifier and runs the verifier function. Okay. Okay, now let's see it is prover function and a verification key. Okay, after you write a smart contract, build it by running the npm run build command. The build process compiles the TypeScript code into JavaScript and outputs the smart contracts JS file. From this file, you can run a prover function to run your smart contract, generate a verification key to deploy your smart contract. I mean, we'll see that. Okay, while the prover functions runs in an end user's web browser, the verification key lives on chain for a given zkAPP deploy account and is used by the MINA network to verify that a zero knowledge proof has met all the constraints defined in the prover. A verification key is required to create a zkAPP account. You can also use the verifier function or verification key to verify proofs of chain. Uh, yeah, I mean, that's interesting. We can also use a verifier function and verification key to verify proofs of chain, right? I mean, that's interesting. Yeah. Okay. Deploy a smart contract. Uh, zkAPP developers use the zkAPP CLI to deploy smart contracts to the MINA network. The deployment process sends a transaction that contains the verification key, that is an output of the verifier function, to an address on the MINA blockchain. So the verification key goes as part of the transaction. Okay. When a MINA address contains a verification key, it acts as a zkAPP account. Okay, the regular MINA account can receive any transaction. You can specify permissions. So a zkAPP account can successfully receive only the transactions that satisfy the verifier function. And the MINA network will reject any transactions that do not pass the verifier function. Okay, makes sense. When you deploy a zkAPP to a new MINA address, when you deploy a zkAPP to a new MINA address, the MINA protocol charges a 1 MINA fees for account creation. This fees is unrelated to zkAPPs and helps to prevent civil or denial of service attacks. Deploy a zkAPP UI. A zkAPP consists of a smart contract and a UI to interact with it. To enable users to interact with your smart contract in a web browser, you build a website UI and then deploy its interactive UI as a static website. Choosing to host that offers a global content delivery network ensures the best experience for all users. Hmm. How users interact with a zkAPP. To use a zkAPP, end users must install a wallet that supports interactions with zkAPPs. After a zkAPP is deployed to a host, for example, mycoolzkAPP.com, end users can interact with it. The user visits mycoolzkAPP.com. The users interact with the zkAPP and enters the required data. The proof function in the zkAPP generates the zero knowledge proof locally use. Okay. Prover private, the data is never seen. List of updates, state updates. Okay. The user interacts with the zkAPP and enters the required data. For example, if this is an automated market maker, the user might specify to buy X amount of ABC at Y price. The prover function in the zkAPP generates a zero knowledge proof locally using the data entered by the user. This data can be either private, the data is never seen by the blockchain; public, the data is stored on chain or off chain, depending on what the zkAPP is specified as required for a given use case. A list of state updates called account updates to be created by the transaction is generated. The account updates are associated with this proof. The user selects submit to chain in the zkAPP UI. Okay. The user confirms the transaction on their wallet. The wallet signs the transaction containing the proof, then the associated description of state to update. The wallet sends the transaction to the MINA network. The MINA network receives this transaction and verifies that the proof successfully passes the verifier method listed on the zkAPP account. If the network accepts this transaction, this proof and the requested state changes are valid and are allowed to update the zkAPP state. The end user's privacy is maintained because their interaction occurs locally in a web browser using JavaScript on the client. Okay, how state is updated on chain. The zkAPP account gets updated on chain. When the prover function runs in a web browser, the smart contract outputs a proof and some associated data called account updates. This is very important actually. I've read about this before, but yeah, account updates are something, these are very important. So account updates, they are sent as part of the transaction, like as I understand it. And these account updates are a JSON object, JSON plain text description that describes how to update the state on a zkAPP account. So how the state is updated on chain. The zkAPP account gets updated on chain whenever the prover function when the prover function runs in a web browser. The smart contract outputs a proof and some associated data called account updates that are sent to a zkAPP address as part of the transaction. The account updates are a JSON plain text description that describes how to update the state on a zkAPP account. The integrity of these account updates is ensured by passing a hash of the account updates as a public input to the smart contract. Okay, I mean, this is something new. The integrity of these account updates is ensured by passing a hash of the account updates as a public input to the smart contract. The account updates must be present and unmodified for the verification function to pass successfully when it runs on MINA. In this way, the MINA network can confirm the integrity of both the proof and the associated account updates that describe how to update the zkAPP account state. So when the prover function runs in a web browser, the smart contract outputs a proof and some associated data called account updates that are sent to a zkAPP address as part of the transaction. The account updates are a JSON plain text description that describes how to update the state on a zkAPP account. The integrity of these account updates is ensured by passing a hash of the account updates as a public input to the smart contract. The account updates must be present and unmodified for the verification function to pass successfully when it runs on MINA. In this way, the MINA network can confirm the integrity of both the proof and the associated account updates that describe how to update the zkAPP account state. zkAPP state on-chain state that describes on-chain state describes a state that lives on the MINA blockchain. Off-chain state describes a state stored anywhere else. Off-chain state is, I guess, a bit tricky with respect to MINA because I guess MINA is open for any sort of off-chain state like IPFS, centralized storage, or anything. On-chain state, okay, now this is important, right? Each zkAPP account provides 8 fields of 32 bytes each of arbitrary storage. Now that's not much actually. 8 fields of 32 bytes. You may store anything here as long as it fits in the size provided. 8 fields of 32 bytes each. So it's, I think, 256 bytes. Yeah, 256 bytes. It's not much. If you anticipate your state to be larger, or if the state accumulates per user with your zkAPP, then use off-chain state instead. Okay, I mean, as part of this streaming, right, I would have to see how the off-chain state works, like, because off-chain state seems to be very important part for zkAPPs, useful zkAPPs. For larger data, you might want to consider storing the root of a Merkle tree or a similar data structure within your zkAPP's on-chain storage that references self-hosted off-chain state stored as elsewhere. MINA doesn't offer an out-of-the-box solution for off-chain storage. When the zkAPP runs in a user's web browser, it can insert a state to the external storage such as IPFS. When the transaction is sent to the MINA network, If it accepts the zkAPP transaction, then proof and state are known to be valid, so updates are allowed. Then the zkAPP transaction can update the root of the Merkle tree that is stored on chain. So what it is saying is, when the zkAPP runs in a user's web browser, it can insert a state to an external storage such as IPFS. When the transaction is sent to the MINA network, if it accepts this zkAPP transaction, then proof and state are known to be valid, so the updates are allowed. Then the zkAPP transaction can update the root of the Merkle tree that is stored on chain. Okay. zkAPP programmability is not yet available on MINA mainnet. You can get started now by deploying zkAPPs to the Berkeley testnet. zkAPPs getting started. You can start writing zkAPPs. Okay, let's start with some real code. I mean, we are reading a lot. Uh, Testing locally. So, I mean, before doing that, this is okay. ZK Lightnet, huh? We can use ZK Lightnet, but right now it's okay. So, okay, let's open the project. Let's talk about the project. So, let me move my terminal here so you guys can see what I am doing. Okay, and okay, cd web3 mina, not Minapolis, cd Mansfield. Okay, and we will open this Mansfield, which is not open somehow, so we'll open it again. Oh, it's not opening. Okay, maybe it's the issue. Okay, now it's opened. Weird. Okay, so what we can do, so let me walk you through the project structure of it, or I don't know, like we can you know you can create a new project so that you can start everything from scratch. Yeah, I mean that makes more sense. So we'll do zk project counter app. We'll go with accompanying UI as well. No, not GitHub pages. Yeah, we'll love the TypeScript and Tailwind and everything that you can give to us. So okay, I mean, so I think it makes sense to you know let's just see what it is doing. Yo, yo, yo. Okay, setting up the installation and part and everything. Okay, so cd counter app Okay, let's open this. What does this have? So it does have contracts, and in contracts it does have add contracts. So if we'll take a look at the UI later, and we'll just yeah, I'll just look at the counter app. And does this have a counter app? No. Okay, no worries. So this is the contract. We'll just keep ourselves limited to contract. So in contract, what do we have? Dot GitHub, not relevant. Build, it's for build files. Keys are account keys. We'll talk about them later. But the main meat is in the SRC. So in SRC you have add, and you can see, basic examples. The add contract initializes the state variable a num to be field 1 value by default when deployed. Here it is, initializing the field variable, the num variable to be value 1. And we have this update method, current state, and we are just changing the update method. With the update method we are just changing the value to 2. So that's the idea. uh, you know okay, now let's open this here. Hmm, how can I move it? How can I move it? Terminal position to downward. I don't know. Uh, Panel position, bottom. Okay. So you can see, and if we go to contracts, cd contracts. Okay. First of all, let me do npm install. I think it is already done. Npm run build. Okay. Zk deploy, zk config. Okay, create a name, counter app, MINA GraphQL API to deploy to, and we are going to use the Berkeley API. So this is the URL for the Berkeley, and it is on documents as well. I am going to use or account 1, MINA or account 1. Okay, zk deploy. We'll just see. Cannot read properties of undefined. Huh. Okay. zk zkAPP CLI. This is the error that's specific to my machine. zkAPP CLI. Let's just see. Hmm. Counter app. So it is generating the. Okay, before deploying, I should have also shown you the test cases, which is also amazing. Like, okay, we'll also deploy it here. Oh fuck. Okay, counter app. I should have said yes, actually. Yes. Okay. It will send the network, and we'll be able to see the transactions there. But that's not the case. Yeah. So about this test case, right? Like, you have this in the test case, we can spin up a local blockchain with mina.local blockchain, and we have these accounts, and sample accounts in the test accounts in this local instance, and we can deploy a new chain instance inside a test case, which is amazing. So yeah, I mean, now I want to npm link look package. Huh. Okay, so npm link. So now I have created a link of counter underscore app cd ui npm link counter underscore app. Okay. Okay. In UI, where is the counter underscore app? No. npm install local package. Hmm. Uh-huh. I don't know. Hmm. One linking. Okay. Let's try with one. Okay. CD contracts. One link. I mean, okay. I think CD contracts, CD UI. One link counter underscore. Ah, not one link. One link. Okay. Hmm. In the UI, but where it is? Like, yeah. Okay. Okay. Let's see. Pages index.js import. Okay, that means it is installed somehow. Okay, so let's see. The transaction is applied and account updates are there. Okay. Oh, these are like my Minneapolis game. Hmm. What about this second account? Damn, bro. Okay. Hmm. Okay, so what's the status? Now we've got the, zkAPP. Let me see. Uh, so uh, the we deployed the zkAPP, and we should have gotten the zkAPP address. That's the idea. Okay, so let's see. Transaction hash was this one. zkAPP transaction. Fees pair was this one. Account updates and zero mina. I guess. Okay, and this is the account. Okay, so I'll just copy this and we can keep this account here as a zkAPP account address for add contract. Okay, so we got this zkAPP account. Now what we want to do, our target is our target is to make the state change from UI. I mean that's our target. And import local blockchain, and that's okay. And okay, let me see what is inside this build interact.js. Okay, Mina network ID and JSON parse. Okay, this script can be used to interact with the add contract. After deploying it, we call the update method on the contract and create a proof and send it to the chain. The endpoint that we interact with is read from your config.json. This simulates a user interacting with the zkAPP from a browser, except that here sending the transaction happens from the script that we are using. And we are using your pre-funded zkAPP account to pay the transaction fees. In the real app, the user's wallet would send the transaction and pay the fees. Okay, so Mina network and Mina private key from o1Js. Okay. Hmm. 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 So we have a config.json where it is, where is the config.json? This one, counter underscore app. Hmm. Okay, and if we do node build slash counter underscore app, so now the transaction will be done, and this is done from the UI, allegedly. Allegedly this is done from the UI. Okay, so what it is doing is it is reading the config, reading the fee pair path, and zkAPP is 68, key path, fee pair key, network, fee pair address, and it is making a transaction, and it is getting a transaction URL. So that's how they are doing it. Hmm. Hmm. Okay. mean, mm, that's nice, but you know, in a real world, we want to do a transaction with wallet connection, right? Like, you want to make a transaction by connecting the wallet and all that, stuff. So I guess we should focus on that part. So let's do one thing. Okay, let's integrate you know now from now on we'll focus on this project. Okay, so we have this Mansfield, and yes, we have, yeah, I mean, we have the, and in Mansfield as well we have a interact, you know yeah, we have interact, so that way we would want to interact with the we would want to interact with the contract using real UI. So, okay, transactions are updated. Transactions are still pending. Nice. I mean, not really nice. You see, strings values changed to 3. We increase the value 2. Okay. That's some nice stuff. Okay, now let's go to Mansfield actually. CD Mansfield. CD Mansfield. CD UI. Run dev. Let's see, one run dev. Oh, okay, so let's see what we have now here. We should have a barebone next application. Yeah, we have that. Okay, now we want what we want to do. I'm going to close this because this is not useful anymore. Huh. Okay, and I guess I have the counter application. F3 Mansfield. Okay, one run test. Okay, CD contract. So there is a counter program as well. I'll just walk you through the counter. So counter does have a field value 1, and we set the counter, we can increase the counter, and we can decrease the counter. That's the whole idea about counter. Yeah. zk deploy, I mean zk deploy counter app. Yeah, let's send it. Okay, so this is the counter application. Okay, this is the counter application. Now we can interact with this counter application as well. If I go to config.json, okay, this is the public key of this counter application. Okay, let's see. The test cases are there, should correctly. We can also add a test case to decrease the counter, decrease the counter. Okay. Okay, bun run test. Let's see. Yeah, okay. So let's try to interact with the counter. We'll try to do it with add not slash dot slash counter, and we'll do it with for the counter deploy alias. Okay, we can do this import add from dot slash add. Okay, deploy alias should be there. Config deploy alias is deploy alias. Okay, vpair mina network set active instance. Okay, no, I think we'll have to do that. Okay, we can only do this. So deploy alias json.parse json app key mina network fee config fee set active instance new counter. Okay, compiling the contract counter, call increase counter. Okay, transactions and okay, and deploy aliases. What is the deploy alias for this counter and this counter app node? Hmm. Okay, it will create a transaction, it will send the transaction. Invalid proof, failed to send transaction, couldn't send zkAPP command. Okay, that's weird. Let's see what can go wrong. So this script can be used to interact with the, let's say, counter contract after deploying it. We call the update method on the contract, increase counter. Okay. Create a proof in the endpoint that will this simulates a user interaction with the zkAPP from a browser, except you're sending a transaction happen from the script. And we are using a pre-funded zkAPP account to pay the transaction fees. Okay, and we can remove this. Import fs from fs/promises. Import mina and private key from o1Js. Import counter from counter. Okay, we need to provide deploy aliases. Type config deploy alias string and key path fee pair key path fee pair aliases config json fee pair aliases zkAPP json.parse append key path fee pair path zkAPP path mina.network fee set active instance fee pair path new counter zkAPP address, right? zkAPP key private key zkAPP key from private key. Okay. Counter.compile. Are we providing anything in counter? No, right? Yeah. Counter.compile console.log zkAPP success. Send transaction is there. Yeah. And fee pair key is there. Invalid proof in progress. Why is that? Build transaction and create proof. Couldn't send zkAPP command. Invalid proof. Okay. Okay, let's see. Okay, let me also share this. So this will also be a very useful exercise, in seeing how we can, if any such issue happens, what are my usual flow, right? So I usually open just, Discord and go to build transaction and let's print the console.log transaction transaction. Okay, why is that the case though? Okay, so it's here. Okay, so okay, let's go to zk developers. Okay, okay, let's see. I got this error when sending transactions. Couldn't send. No, this is not invalid proof in progress. What the fuck does that mean? Yeah, I mean, hmm, hmm. Verification keys are different, huh? Verification keys are different. Okay, let's do one thing though. Okay, let's change it. Value 3, let's say value 3. This might be the case though. Value 3. Okay, now in here as well I need to change it. Value 1 to value 3. Okay, okay, run build, run test. Maybe the contract is not deployed yet. That might be the case as well. Now we can do zk config counter f3 mina auto count 1 zk deploy counter f3 counter Yes, please. Okay, so this is the pending transaction. But the issue is there, huh? Yeah. Also, it's face this issue. Just also. Hmm. See, so what it is saying is change wording of the error, verification failed, invalid, proven, progressive verification is missing, container method verification key of the compiled contract. What does that mean? Okay, let's see. Build, interact, yes. Okay, and counter F3 cannot find module. What? भाई है ना. When run test. Hmm. Okay, and what's the change here? Okay, counter. Hmm. Pin node. When run build. Counter from where it is. Hmm. Okay. Okay. What to do in this case? Why it is not showing the, yeah. No. No. But it was working. Error module not found. Very weird, right? Yeah, I mean, cannot find module, huh? See, very weird, yeah. Interact.ts. Hmm. Okay, anyway, let's see this. That's okay. Hmm. 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 What to do now here? Maybe go back to the add one. Maybe, yeah. Try to do the add one. There is some issue with this script as well. Config JSON. What is this issue inside? But there is this issue inside add as well. Ulta pin. Okay. Pun install. Pun run build. Pun run test. Okay, node. Okay. Let's see. Will I get anything? Oh, that might be the issue. No. Okay. Direct to JS counter app 3. Cannot initialize. Hmm. Now what is that? Cannot access uninitialized variable. Now what's that? Yeah. Cannot access uninitialized variable. And we can remove the package JSON. Hmm, that's nice. Okay, failed to send transaction, couldn't send zkAPP command, invalid proof in progress. So, okay. Uh, Contract is not deployed. Hmm. For EV, let's see. So my wallet address is, I think, 4EV, but this one is WS. Okay, and let me see if it is the key, account key. Yeah, CH. JCHWS. So it's one, this one is done. Okay. And I can remove the counter app as well. Okay. Now, and let's see counter app 3. Okay. This one, this one is zkAPP transactions, transaction hash. Okay. This one is also, uh-huh. Hmm. So the account state is there, or private key, though I don't know. But what's the issue with this one? Uh, okay. No, there is some issue. Hmm. Verification key hash 3318. Hmm. Hmm. Let's see, then let's deploy a new account. zk deploy. Yes. Okay, and let's see. Node. Okay, I think it will be done then. Hmm. Invalid proof in progress. Mm-hmm. Check verification key that would compare the verification keys. Okay. Okay. I'm seeing. Oh, seeing this error. I'm seeing this error. I'm facing this error. Repeatedly. This is happening frequently. Never I try to send a transaction using node script. Interact script. Interact script. Also the associated GitHub issue. This sure. How do I resolve this? Does anybody know? The fuck is this, bro? No. What's this? Is this another? Is this another? Is this anything? Mm, well, I just want to. Why? Mm, hmm. Does anybody know? Does, does anybody else know how to resolve this? Okay. So I guess we are stuck on this, and you know, somehow the transactions are failing. Couple of transactions are failing. So yeah, I mean, let's see how it goes, and maybe I'll do another stream for the UI. This is really difficult stuff, guys. So yeah, see you guys, and yeah, hope you enjoyed this stream, and as much as I enjoyed it. So yeah, see you guys again.